The C programming language is a valuable tool for computer engineering because it combines the ease of high-level language programming constructs with direct access to the bits in the computer. C provides a number of data types: characters, different types of integers, including signed and unsigned, as well as integers of various lengths, floating point numbers of various resolutions, and structures that allow us to combine heterogeneous data types. C does not provide a direct Boolean type, but we can use, for example, the constant facility, also known as pound define, in order to create constants like true and false. Much of the work of C is done in expressions. Here we have several different types of expressions. We add two numbers together. We shift a value by 3-bit positions. We compare two different numbers, and we test the equality of two different expressions. Functions allow us to abstract pieces of code and to use them as building blocks in the design of programs. Here we have a simple function addargs that takes in two arguments, a and b, and returns their sum. We can use addargs in another function. We can call it twice with different arguments. In each case, addargs returns the values appropriate to those arguments. Functions, in combination with the stack mechanism, provide the important mechanism of recursion. Factorial is a mathematical function that can be implemented using recursion. So, if we want the factorial of 2, we can call the factorial function on 1. From there, the factorial of 1 calls factorial of 0. At this point, the factorial of 0 is defined to be 1. We can compute from there the factorial of 1 and return it to the original function call, which then computes the factorial of 2. Printf and scanf are library functions provided by C that allow us to print values and to read them. In this case, we print a string that requests a number, we then read it. We do the same for another value, we compute the result, and then we print it. Programs need to make decisions based on the value of data. This if statement evaluates a less than b. If that's true, it assigns C the value of a plus b. If it's false, it assigns C the value a minus b. The value of C printed after the if statement will depend upon what values a and b held when the if statement was entered. Arrays allow us to organize data. We can organize numerical data in arrays in order to represent mathematical matrices. Here we've declared a matrix. Here we've declared an array A1 of size 5. We then perform one operation on the 0th and the first elements. We can use a variable I to compute the index that we want to access. So here we access the ith and the ith plus 1th elements. It's also good programming practice to define a name for the size of an array. Here we've defined n to be 5. Iteration is a powerful tool in programs. This while statement provides one type of iteration. It tests a condition whether count is greater than 0. When count is no longer greater than 0, it stops iterating. This for loop provides a more structured form of iteration. Here it is incrementing through values from I equals 0 through I equals n minus 1. You'll notice the condition is I less than n. The body of this for loop adds together the values of an array in order to create the sum of all those values. The C scoping mechanism allows us to use curly brackets to put one loop inside another. The outer I loop is executed n times. For each execution of the I loop, it executes the inner J loop n times. Pointers allow us to access memory. A pointer is an address in memory. Pointers need to be used carefully, but they are a very powerful tool within the C programming language. Here we have a declaration for a pointer to a record called P0. We also use the ampersand to create a pointer to the variable A. This pointer allows scanf to modify the value of the variable A. A couple of examples show us both the power and the dangers in pointers. Here we have declared a variable foo and another variable fob. We have a pointer, baz, that points to foo. We have another pointer, foz. But when we add 1 to this pointer value, we now cause the pointer to point to somewhere that it should not point to. When we dereference baz using the asterisks, we reference the value that's pointed to by baz. In this case, 5. We then add 1 to 5 and store the result in the fob variable. malloc and free are C library functions that allow us to manipulate the heap. In this case, we allocate a block of integers on the heap of size n bytes, and we store the pointer to that heap element in the pointer I block. We can use free to unallocate memory that was previously allocated using the malloc function. When we free one block, that leaves the other blocks on the heap untouched. A character defines a single symbol. We can use libraries to allow us to represent a broad range of symbols from many different languages. We represent a string of symbols as an array of characters. We set the length of that array to 1 larger than the total number of characters we want to be able to put into it. We use a null character, 0, in order to signify the end of the string. This loop tests S1 against another string, S2. It tests character by character. When it finds that the two strings disagree at a given position, it sets same to false and exits the loop. Thanks for watching.